Hi, in this video, we're going to discuss an example of integration of a rational function. So this rational function is the type 2 rational function because it is possible to linearize this and some of its linear terms are repeated. Basically, we can write down this rational function as x minus 1 multiplied as x plus 1, which is x squared minus 1 in the square, right? So in this case, it is written as x minus 1 in the square multiplied to the x plus 1 in the square. So it is possible to write down as a multiplication of the linear terms, but some of the linear terms are repeated. So in this case, we can expand this as the a multiplied to the x minus 1 plus b multiplied to the x minus 1 in the square plus c multiplied to the x plus 1 plus d multiplied to the divided to the x plus 1 in the square. So what we need to do is we need to give the common denominator. Common denominator is going to be x minus 1 in the square, x squared minus 1 in the square. So which terms we need for the first term? It's x plus 1 in the square multiplied to the x minus 1. So we need x plus 1 in the square for the second one. X minus 1 in the square multiplied as x plus 1 is needed for the third term. X minus 1 in the square is needed for the last term. So before we give the common denominator, let's simplify those terms first of all. So let's simplify the first one, which is x squared plus 2x plus 1 multiplied to the x minus 1. In this case, it's going to be x cubed plus 2x squared plus x minus x squared minus 2x minus 1. So as a simplification, we will obtain x cubed plus x squared minus x minus 1. So let's simplify the coefficient before the c as well. So it's going to be x squared minus 2x plus 1 multiplied to the x plus 1. So if you simplify everything, we're going to obtain x cubed minus 2x squared plus x. So we multiply the x to all the terms from the first bracket. And now let's multiply now 1 to all the terms from the first bracket. It's going to be plus x squared minus 2x plus 1. So it's going to be x cubed minus x squared now minus x plus 1. Nice. So now we're going to get the common denominator for the last, so for the right hand side part basically, and let's see what we'll obtain. So the a is multiplied to the x cubed plus x squared minus x minus 1 plus b multiplied to the x squared plus 2x plus 1 plus c multiplied to the x cubed minus x squared minus x plus 1 plus d is multiplied to the x squared minus 2x plus 1. So what we need to do now is we need to write down the terms with the x cubed separately, the terms with the x squared separately, and the terms with the x and without x separately as well. So let's write down first of all the terms with the x cubed. So the terms with the x cubed are a plus, so there are only two x cubes, right? So the a plus c. So now we are going to write down the terms with the x squared. So I see the x squared here, here, and here. So there are 4 terms with the x squared. The x squared is going to be a plus b minus c plus d. So now we need to write down the terms with the x. So I see the terms with the x here, 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 and here. So let's write this. So x is going to be minus a plus 2b minus c minus 2d. And the rest is going to be the terms without any x. So it's going to be minus a plus b plus c plus d. And please note that all of this thing should be equal to the 1, right? Because this is the numerator from the left-hand side part. So what we did is we wrote down this rational function as, say, the first rational function as the second one. So when we give the common denominator, the denominators are going to be the same. and correspondingly their numerators should be the same as well. So I've got the two polynomials on the left hand side and on the right hand side. So in order to be equal, so they have to get the same coefficients before the corresponding terms of the powers of the x. So here basically on the left hand side, I have the x cubed, x squared, x in the free coefficient, while on the right hand side I don't have any term with the x. It means that the coefficients before the x is equal to the 0. Basically, you can assume that you have the x cubed, but it's multiplied to the 0. So you have the x squared, but it's multiplied to the 0. And you have the x, but it's multiplied to the 0. So basically, you have the polynomial on the right-hand side part, and you have the polynomial on the left-hand side part. And in order to equalize them, we're going to equalize the coefficients before the powers of the x. So first of all, we need to write down that a plus c is equal to the 0. A plus b minus c plus d is equal to the 0. Minus a plus 2b minus c minus 2d is equal to the 0. And the last term without any x is equal to the 1, because on the right hand side part I've got 1 as a term without x. It's going to be minus a plus b plus c plus d, and this is equal to the 0 to the 1, sorry. So I've got the system of linear equations with the 4 unknowns and 4 equations. We're going to solve this. So let's try to figure out how we can solve this easier and quickly. So from the first equation, we find out that c is equal to the minus a. So I'm going to substitute this to the second equation. So if I substitute instead of minus c, minus a, it's going to be plus a, right? So with this a on the first, we are going to have 2a. So it's going to be 2a plus b plus d, it's equal to the 0. So this is when we substituted the c is equal to the minus a to the second equation. I'm going to substitute this to the third equation as well. It's going to be minus a plus 2b minus, so instead of c, I'm going to put minus a, right? So minus 2d. So this is equal to the 0. Do you see that minus a is equal to the plus a? So it's going to be cancelled with the minus a here. So the second equation is really important because it tells us that 2b minus 2d is equal to the 0, right? It means that b is equal to the d. Only in this case, 2b, so 2b minus 2d is equal to the 0. It means that b minus d is equal to the 0. It means that b is equal to the d. So I'm going to substitute c is equal to the minus a to the last equation as well. So we're going to obtain minus 2a plus b plus d is equal to the 0. So do you see, so I've got really good equations, like this equation and this equation are really similar, except the first terms, right? So what I can do is, and this is equal to the 1 again, sorry. So what we can do is, we can just add them. So let's add these two equations. So what we'll obtain is, so minus 2a is going to be cancelled with the plus 2a when we add them. We're going to have 2 multiplied to the b plus 2 multiplied to the d, it's equal to the 1. Okay, so since we know that b is equal to the d, we obtain that 2b plus 2b is equal to the 1. From here, it's clear that b is equal to the 1 over 4, right? So since d is equal to the b, it means that d is equal to the 1 over 4 as well. So we are going to substitute b and d to the last equation, for example. So we're going to obtain minus 2a plus b plus d is going to be 1 over 2 is equal to the 1. So since this 1 over 2 can go to the right-hand side part, we're going to obtain minus 2a is equal to the 1 over 2. It means that a is equal to minus 1 over 4. So that is why c is equal to the plus 1 over 4, because c is equal to the minus a. We can see this from the very first equation. So what we're going to do is, I'm going to substitute the values of the coefficients to here. So basically, a is going to be equal to the minus 1 over 4. So let me write with a different color. So A is going to be equal to the minus 1 over 4, B is equal to the plus 1 over 4, C is equal to the plus 1 over 4, D is equal to the plus 1 over 4, and we're going to integrate them. So you will see that the integration is going to be very much straightforward. So basically, this integration term, dx over x squared minus 1 in the square, can be written as 1 over 4 with the minus divided as x minus 1, its integration, plus 1 over 4 divided as x minus 1 in the square dx, plus 1 over 4 multiplied to the integration of dx over x plus 1, plus 1 over 4 integration of the dx divided to the x plus 1 in the square. So we're going to integrate them. So the integration of the first term is going to be minus 1 over 4 multiplied to the ln of x minus 1. The integration of the second one, if we take out the 1 over 4 from the brackets, it's going to be x minus 1 in the power of minus t plus 1 divided to the minus t plus 1. So the plus the integration of the third term is going to be 1 over 4 multiplied to the ln of x plus 1. And integration of the last term is going to be 1 over 4 multiplied to the x plus 1 in the power of minus t plus 1 divided to the minus t plus 1. So let's simplify everything here. So we can take out 1 over 4 and 1 over 4 from here, and it is going to be written as ln of x plus 1 divided to the x minus 1. And we can take out 1 over 4 and 1 over 4 with the minus again, because minus 2 plus 1 is going to be minus, right? So minus 4, 1 over 4 can be taken out from the brackets, and what we have here is 1 over x minus 1 divided plus 1 over x plus 1. So if you simplify everything here, it's going to be minus 1 over 4. If you give the common denominator, it's going to be x plus 1 here. So here it's going to be x minus 1. Plus 1 is going to be cancelled with the minus 1. We're going to have 2x on the numerator. 2x divided to the x squared minus 1. Plus the constant. So we can simplify this a bit. It's going to be 1 over 4 multiplied to the ln of x plus 1 divided to the x minus 1 minus x divided to the 2 multiplied to the x squared minus 1 plus the constant. So this is an example of the integration of the rational function, which is a little bit too long, but it reveals a lot of structural issues connected with the integration of the rational functions for the case number 2.